The Internet is arguably the quintessential network of our times. Whenever one talks about networking, one immediately thinks about the Internet. And in this module, we will indeed use many examples that come from Internet protocols and examples that refer to the Internet. But to fully appreciate the Internet, one has to go back in history and see where it comes from, where its roots lie in the Arpanet of 1969, and why the Arpanet was designed in the way in which it was. Because when one understands that, then a lot of the decisions that were made for the Internet eventually are easy to understand. In this video, we will spend about half the time to discuss the context in which the Arpanet developed, and then the other half to talk about aspects of the Internet that we need before we proceed to our actual course content. To talk about the Internet, one has to go back to 1969 and think about the world and think what the prominent forces in the world were back then. 1969 was in the middle of the Cold War. Remember, because I know many of the viewers are younger students, and they may not even recall the Cold War. But remember that the Cold War was this animosity that developed between the Soviet Union and the United States and its allies, more or less at the end of World War II. Both of these blocks started to weaponize, they started to deploy missiles, and one of the primary developments in those terms was the fact that you had nuclear bombs on top of missiles that were planted in these various blocks and that were pointed at one another. And typically with a push of a button on one of these sides, you would get a missile that would flew over across the sky, and it will end in another country about 30 minutes, half an hour, and suddenly a city will be gone. Just like Hiroshima and Nagasaki disappeared during the Second World War, here some other town or city would just be wiped off the earth. What kept this in a somewhat stalemate position was the fact that both these powers had these missiles that were pointing at one another. And the assumption was that if one party were to fire, the other would also fire, and you would have a disaster in both of these blocks. So nobody pushed the button, thankfully, and none of these intercontinental ballistic missiles was ever fired at another country. However, we did have all sorts of interesting regional conflicts. So in Africa, in Asia, you had parties who were supported by players from these two blocks, and they fought what was known as proxy wars. Often the intention was to gain control over a certain area, certain space in Asia or in Africa. And one of the goals was to try and move your missiles closer to the other block so that you can get your missile to land on that side much quicker than waiting half an hour. Those who are interested in history may go and look at the Cuban Missile Crisis, where some of the Soviet missiles were deployed in Cuba, which is right on the border of the United States. And this made the United States very, very scared, because suddenly the Soviet Union was able to ask Cuba to fire missiles, and then within minutes, some destination city in the United States would be destroyed. Picture that you are looking at right now is a museum of one of these missile silos. In this particular case, this museum is at the southern tip of Arizona, very close to Tucson. So if you look at Tucson and go south a little bit, you will find it. You can try and spot it on Google Maps, but it may be easier to search for the Missile Museum in Tucson and then go straight to it. At some point, the Cold War ended. For many people, this was when the Berlin Wall fell and the Soviet Union disbanded. We can argue about some of the dates, but that's the approximate end of the Cold War. And after that, and even leading up to those events, the use of these ICBMs, so intercontinental ballistic missiles, were limited by all sorts of treaties and so on. So there was an active attempt to try and reduce the number of missiles. The reason why this one is still in close to Tucson in Arizona is the fact that it was never loaded with a nuclear warhead, so that poison never went into the silo, and it was never filled up with fuel, because the rocket fuel used is also poisonous, and that would also have contaminated the environment. So this silo was never armed, in a sense. From the silo, as an aside, they could destroy one of 3 cities. Which cities, to the best of my knowledge, is still classified information. They could, from inside the control room, select, send this missile to city A, city B, city C, and then, as I've said, half an hour later, that city would be gone. Just for the sake of completeness, there wasn't a single button in this control unit to press. There were 2 buttons on opposite walls, so you really needed at least 2 people to cooperate to fire this missile. Now, what does this have to do with the internet? The problem that was faced by both of these superpowers was the fact that a large part of their infrastructural city may just disappear. If someone on the other end of the globe pushed the button or 2 buttons, then this city may be gone. And the question that was faced by these superpowers was, can we build a network that has no single point of failure? In other words, even if a city disappears, and even if it is where the headquarters of this network would be, would it still be able to continue running? And therefore, in the United States, as a research project, they started building this network that eventually would become the Internet. The agency that funded the project was one that slotted into the Department of Defense, and it was known as the Advanced Research Projects Agency, or ARPA, and sometimes the D was put in front of it to call it DARPA, depends on the time period and so on. But this network that was initially constructed from about 1969 onwards was initially known as Arpanet because it was funded by ARPA. In 1969, 5 campuses were interconnected. That included 4 universities and 1 research institution. This system was built. The idea was never for it to carry any classified information. It was rather intended as a research tool, so universities, research agencies, museums, those types of places were allowed to connect to this internet. Initially, when they started building it, they used components that, if you look at the names now, sound very strange. But over the next 10 years or so, they started settling on the sort of systems that they would use. So most of the protocols that are really important were introduced around 1970 or thereabouts. Now, how do you build a network that has no single point of failure? And the answer is more or less that you delegate as much as you possibly can downwards. So you do not control this network from the top somewhere and say, this is how this should be done. You say, I'll do my little bit here, but you do your bits there. And so we go down this hierarchy, and at the lower levels, things can still operate even if this top level is gone. So this delegation of authority, of responsibility downwards, is a key element of the internet. Another aspect is redundancy. If you need something that is critical to operate this network, then you would build multiple instances of it. In one of our forthcoming videos, we will talk about the domain name system, and that has nodes that are known as the root name servers, and they are at the root of this name tree that we will talk about. And in order to ensure that you cannot take out the root and suddenly the whole network is down, they replicated that. And there were 13 of these initially. In a sense, there are still 13, and they were placed all around the world, mostly in the United States initially, but also in a number of other countries. So even if you were to wipe out a city in the United States or a city in Europe, then the others would still be able to function, and it would be hard to take out all 13. So there was no single point of failure. In terms of downward delegation, the way that the system works and still works is that resources are typically taken from some central pool and then distributed amongst some regional pools. We will talk about internet addresses quite often in what is to follow. And rather than keep all the spare addresses and all the address assignments at the central place, you split them all up and you send them out to regional places. And then every region operates its net or its address space as a pool, and they then split it up again and hand out some of the addresses to internet service providers and so on. And in this way, if you were to take out anything in the network, the rest should still be able to communicate. Yes, whether you'll be able to talk from this node to that node, that's a good question if you've taken out the backbone here. But if you have any redundancy, if there are multiple paths to get from here to there, then the system should just be able to reconfigure itself and follow another route. And this has in fact happened. We've seen on a couple of occasions where major backbones of the internet were either overloaded or damaged, and the network reconfigured itself simply by falling back to whatever was the secondary option and continued to operate as if nothing happened. One of the biggest tests here was 9/11. In the Twin Towers, you had some really important internet equipment that was destroyed by 9/11, but the internet kept on working despite the total destruction of that part of its infrastructure. An increasing number of universities and research institutions wanted to connect to this internet. And if one looks at the maps of the Arpanet in the earlier days, one can see how it was done. In essence, you would find someone who was already connected to this Arpanet, and you would connect to them. And parties would relay messages to other parties via their own networks. And since traffic was low, we're not talking about an excessive amount of traffic flowing on these networks, because a lot of emails and so on were sent. Because it was not an excessive demand of resources, it meant that parties were willing to carry traffic on behalf of other parties. However, over time, the architecture of the internet changed. As traffic volumes increased, parties were no longer as willing as they once were to carry traffic like a third party on behalf of two parties that wanted to communicate. And it became clear that you needed parties who were specialized parties, in a sense, precursors of today's internet service providers. So they would provide the communication facilities, and those who wanted to connect to the internet would connect to them. But they required high-speed backbone networks to connect to everybody, and in particular to connect to one another. Until the early 1990s, the National Science Foundation in the United States paid for much of this infrastructure, these backbone networks that were required. And obviously they didn't want commercial traffic on it, because they were paying for research, not for commerce. There's another aspect that should be kept in mind. With the internet back then being an academic network, as I've said, a lot of emails were being sent, and also files, papers that people wrote. They wanted to share those papers with other authors, and in fact, by volume, around 1990, the FTP protocol, the file transfer protocol, was the one that carried the most bytes of data. And then, as I've said, email was also very popular. However, two things started to change around 1990. The one thing is that more and more commercial service providers became involved, and as they became involved, it became less and less possible for the National Science Foundation to restrict traffic to academic purposes. The remaining problem was that programs to send email and programs to transfer files were rather obscure software back in 1990. You didn't have the graphical user interfaces that many people are used to nowadays. You would simply use your command line to send email or to transfer a file. And that was simply way beyond the capabilities of most ordinary people to learn to use these strange commands to do something with the internet from which they couldn't really see any benefit. However, what started to change in this sense in 1989, 1990 is Tim Berners-Lee's invention of the World Wide Web. At that time, he was working at the particle lab at CERN, and everything he did belonged to CERN in terms of intellectual property rights. So when he started to build web servers and web browsers, those in principle were proprietary to CERN. They were the intellectual property of CERN. And here he was creating something that he called the World Wide Web, and people didn't have access to it because they had to license the technology from CERN. So by 1993, CERN was convinced that they should release these protocols that he developed to the world on a royalty-free basis, make it public domain, And suddenly other companies saw the opportunity and they started building tools for the World Wide Web. So new browsers arrived on the scene, new servers arrived on the scene, and so on. And suddenly people had a graphical user interface where they could click on a link and be provided with information. So someone could set up a web server where they made the latest sports results available. And people could click on that and they could see what the results were at that moment without having to tune into some radio station and wait for some time when they would announce the scores. Other people wrote games and they made those available via this World Wide Web. Rather than typing in a fairly hard to remember FTP command, people could click on a link in their browser. This was 1993, 1994. As we've said in a previous video, one of the prominent bookstores in the world, Amazon, which was a bookstore back then, opened its doors in 1994. So those technologies took it to a step where ordinary people could use it. The volume of traffic started to shift. And it wasn't long after 1994 that the volume of data that were web-based traffic exceeded the volume of traffic that was used by FTP. So at that point, there was this conceptual shift from the internet as a tool for specialists to something that could be used by anyone. We should also talk about the spelling of internet. The fact is that the internet uses technology that one can use to build an internet. So if you have a couple of networks, you can use the technology that is used in the internet and you can link those networks together. And that happens in a number of specialized places where people just want to build a tiny network and they use internet technology. However, there is this one big internet that grew out of the Arpanet and became the internet. Now, this latter network, that one and only one that has its origins in the original Arpanet, that one, a lot of people, including me, want to spell that one with a capital I. Whereas if we just talk about an internet, we spell it with a lowercase I. You will see that some people use this convention. I think it's becoming less and less popular over time, or less and less prominent over time, as people forget about the origins or even the existence of other internets. There's a similar question to be asked about the World Wide Web. In this case, it is less clear. The problem is that one often wants to combine words and you get to website and web server and web something else. And the question is, should you then spell those with a capital letter W? So there I've sort of given up and I'm beginning to write web with a lowercase w, even if I use the web, the big one that runs on the internet. This concludes our initial preface discussion of the internet. It consisted of a historical detour to help us understand the historical context in which the Arpanet was conceived, and also helps to explain the way in which the internet evolved over the years and why it works in the way it does at this very moment. We also touched on a couple of notions that are important for the internet to make sense of the internet as an independent network. One of the aspects that we did not discuss in detail was the fact that the internet, or back then the Arpanet, was introduced to show that packet switching is a viable technology. Back in 1969, dedicated lines were the primary way to connect one site to another site, or then dial-up connections. And the Arpanet represented a deviation from this concept in the sense that it used packet switching. Nowadays, most networks, almost all networks, are packet switched. And we find very few that do not make use of some notion of packets. And for that we have to thank the Arpanet, the internet. The next video will be another of these preface videos, and it will talk about the need for standards. See you then.
Music